Hey everybody, so just a little introduction on how this is going to go. We're going to be just going through a couple of assignments today. We're going to be doing this document called Homework 6, and we'll be doing another document called Homework 7. So in Homework 6, we're going to be proving triangles congruent using angle side angle, angle side, and hypotenuse leg. We did cover this topic. We also moved on to CPCTC, which isn't covered in this topic here. So you won't see any of the proofs containing that. So if you do have any questions on any of these, make sure you do ask. Either you can come on to Google Hangouts and you can have a conversation with Mrs. Rinaldi and I, or you can also just send us an email and we can try to explain things that way. I'm just going to move through each example. If you want to do them before I attempt them or show you how to do them, then just pause the video and do it on your own. If you do need assistance on working on them, you can just follow through on the video. What we do ask is that when you're done filling out the assignment, we're going to ask you to take a picture with your webcam, and you're going to attach that to the assignment so that you can receive credit for taking the notes. So you'll get some points for doing that. Also, when we're doing some of these, I might leave some blank and have you do them on your own. So we'll just ask that you'll post that a picture of that, however we ask. Okay, so here we go. So the first question, given segment BD bisects angle ABC and angle BDA bisects angle BDC, prove that triangle ABD is congruent to triangle CBD. Okay, so the first thing we always write is the first given. So BD bisects angle ABC is given. Whenever we see the word, whenever we see that a segment is bisecting an angle, we know that we're going to have two congruent angles. So if we look in our picture, BD is bisecting angle ABC. That would be the angle up on the top. That would make angle ABD congruent to angle CBD. So that's our next statement. And that's by the definition of angle bisector. Definition of angle bisector always follows when we have a segment bisecting an angle. Okay, so the third statement that we're going to write is the second given. Angle BDA is congruent to angle BDC. Okay, so that's a straightforward piece of information. Angle BDA, I'll get 2 arc marks in that one, and angle BDC, that'll also get 2 tick marks because they're congruent to each other. 2 arc marks. That was given. Okay, and nothing else is given to us, but we do notice that the two triangles share a common side. So that's BD. BD is congruent to itself by the reflexive property. So BD is congruent to BD by the reflexive property. So on BD, we'll put it 1 tick mark, and hopefully you can see we have angle, side, angle. So these two triangles are congruent by angle, side, angle. So that's our last statement, is what they asked us to prove. Triangle ABD is congruent to triangle CBD by angle, side, angle. Okay, question 2. Again, if you want to do it on your own before you watch this, just hit pause and try it on your own. So statement given, ST is parallel to UV and ST is congruent to UV. So in the picture, ST is parallel to UV. We show that by putting an arrow on each segment. So we'll write that as our first statement. Okay, when we have parallel lines, it implies a couple of different things. In this case, it implies that we have alternate interior angles. So angle S and angle V are alternate interior angles. And since the lines are parallel, they're congruent. So angle S is congruent to angle V because alternate interior angles are congruent when lines are parallel. And also, another thing is angle T is congruent to angle U. and they're also alternate interior angles. So we actually got 2 out of that one. Okay, they also told us that segment ST is congruent to segment UV. So we'll write that down. Mark it in the diagram by putting a tick mark on each one. And what we should see is we have angle, side, angle. So those 2 triangles are congruent by angle, side, angle. So we're going to write triangle STW congruent to triangle VUW by angle, side, angle. Okay, this one was a little bit interesting because you might have only put one pair of alternate interior angles. Like for example, you might have put that only S is congruent to angle V. And then you might have also noticed that we had the vertical angles. So if you did that instead, you would have got a little bit different answer. You would have got an angle, angle, side, which is still true. So Mrs. Rinaldi and I were talking about this in class last week, that anytime we do have angle, side, angle, we'll also have the possibility of doing angle, angle, side. If not because of like the vertical angles, it would also be true because of the third angle theorem. But in this case, however we did it, we would have found that the triangles are congruent. Okay, our third one. First statement, FH bisects angle EHG. And then remember what happens when a segment bisects an angle, we're making 2 congruent angles. So FH bisects angle EHG, that's bisecting that angle that's on the bottom there. So which 2 angles are equal? Angle EHF is congruent to angle GHF. And that's by the definition of angle bisector. Okay, the next statement is the given angle FEH is congruent to angle FGH. And that was given. So in the diagram, we'll put 2 arc marks on angle FEH and 2 arc marks on angle FGH. Okay, the last thing that we're going to have to do is, since there's no more givens, we have to look at our picture, and you should see that we have the shared side. Anytime we have the shared side, that's the reflexive property, because FH is part of the triangle on the left, and FH is also part of the triangle on the right, so it's congruent to itself. FH is congruent to FH by the reflexive property. Put our tick mark, and what we should see is angle, angle, side, congruent to angle, angle, side. So triangle FEH is congruent to triangle FGH, which I just got from right here, what they wanted us to prove, and that's because of angle, angle, side. Okay, on to question number 4. So in this one, given angle KJL is congruent to angle LMK. So KJL, that's up at the top left. LMK, that's up at the top right. That was given to us, so we're going to write in our first statement, angle KJL is congruent to angle LMK, given. Nothing follows from that. That's just a straightforward piece of information. The next thing is angle JKL is congruent to angle MLK. So JKL, that's the bottom left. MLK is the bottom right. That was given. And now this next one's a little different, sometimes hard to see, but if we look at the 2 triangles that we're trying to prove congruent, JKL, that's the triangle here that's made up on the left. And then MLK is the triangle on the right. They both share the bottom part. So the bottom part is part of both triangles. So KL is the bottom of JKL, and it's congruent to LK, which is the bottom of LK. Most times we would have just written that KL is congruent to KL, but in this case, remember, we're matching up the corresponding parts. So angle K in the triangle on the left is actually congruent to angle L on the triangle on the right. So that's why the K corresponded to L and the L corresponded to the K. So this was the reflexive property. So we'll add in our tick mark. So now we have angle, angle, side, congruent to angle, angle, side. So our last statement, triangle JKL is congruent to triangle MLK by angle, angle, side. Okay, proof number 5. Angle RPQ is congruent to angle RTS. That was given. Marked it in the diagram. The next statement, point R is the midpoint of segment QS. That was also given, and when we have a point that's a midpoint of a segment, it's making two congruent segments. So let's see, which two segments are congruent? R is the midpoint of QS, so that means that QR would be congruent to, how are we going to say it? We're going to say SR, because the corresponding parts need to match up. And that's the definition of midpoint. Okay, nothing else is given, but in this picture we do have vertical angles. So that's angle PRQ is congruent to angle TRS because they're vertical. So now in this picture we have angle, angle, side. So the triangles are congruent by angle, angle, side. Okay, and then our final one on this page, number 6, triangle ABC and triangle DCB are right triangles. That's actually already marked in the picture. That's a new one. We haven't really seen that one yet. Then they're also telling us that side AB is congruent to side CD. Okay, nothing else was given, but we do have the shared side. That'd be BC. So BC in the triangle on the left is congruent to CB in the triangle on the right. And that's the reflexive property. So I add tick marks on that. And now this one's different. In a right triangle, we have the hypotenuse congruent to the hypotenuse and the leg congruent to the leg. So this one's congruent by HL. Okay, so that's it for this one. All right, so one other thing I just want to point out before I end this video. This is homework 7. So in homework 7, this is where you can use all 5 different congruence postulates. Here we have side, 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 angle, side, angle, side, angle, 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 side, or HL. So on these lines, all you're writing is one of those 5, or you're writing not congruent. So we've done a couple like that. Then you're going to go through these proofs. Here it notes, some may require CPCTC. So those are the notes that we did from Friday, where CPCTC came into play. So like number 7, we're proving 2 triangles are congruent, so we don't need to use CPCTC. For number 8, we're proving 2 triangles are congruent, so again, no CPCTC. Onto the back, number 9, we're proving that 2 parts are congruent, 2 angles. So our last reason here to prove that parts are congruent, it's going to be CPCTC. So that's a little hint. So you're proving that these angles are equal. They're going to be equal by CPCTC. Okay, same thing with number 10. You're proving parts are congruent, so that's CPCTC. And then number 11, two parts are congruent, so that's CPCTC. Okay, so make sure that you do come on and talk to Ms. Rinaldi and I between 9 and 11. We'll post the Google Hangouts code for you to join in on. You can come ask us questions there, or if you just want to send us an email at a different time of the day, feel free to do that, and we can do our best to get that information to you or go over any problems we need. So I'm going to post the answers to this along with this attachment. So once you're finished with this, you can look at the answers. Don't just write the answers down though without trying it first. All right, so we'll see you next time.